wouldn't know that this was an actual TI show without some glitches. So
Alright, you get
apparently, we
Should
can
I do
iron that
different
out.
resolutions?
Therefore, our next presenter is
Oh, you like that? That's what
Lee Stewart.
Can you do it?
Take it away, Lee.
Okay, well, we'll see what happens here. Let me see what, okay, well, I guess we'll do with this. What I was going to present was what I've been talking about a little bit on Atari Age with the TI writer converter. I want to write that in Forth to present, eventually to present TI writer formatted files into PDF. And I had thought about doing it to the PDF specifications, but that looked a little more complicated than I wanted to get into. Then I thought about doing it with TeX, which uses a form of SGML, and thought I would have to relearn too much there. So then RTF, rich text file format, came to mind. So that's what I ultimately am going to do. I have to deal with some things like in TI Writer, whether or not you have a header and footer, you get blank space for the header. It's above the margin. It's in the top 5 lines. So you'll get 5 spaces if you print it out without a header. And the footer is the bottom 3, and you still get blanks down there when you print. But RTF moves the header and footer within the top and bottom margin, so I'm going to have to futz with that. Anyway, I had a well problem that took me about 3 days to solve, and I didn't get anywhere with it. So I'm going to instead do a really short, simple tutorial with a number guessing game. Write that in Forth. Let's see. First, there are, some of you are familiar with Forth, but I suspect a number of you are not. Forth is a stack-based system, so that things, to those of you who are used to programming in languages like BASIC and C, perhaps, things look backwards. So if you want to print something, you would have it on the stack, a number on the stack, and then you would print. And print in the most used words, and that's what the term in Forth is for little subroutines, little programs. They're called words, and the bulk of those routines that are in the system are called the dictionary. And the resident dictionary is what you get with the cartridge. There are about 500 words, I guess, in fbForth 2.0. A lot, but it frees up most all of the upper memory. So you have about 24K to write your programs. Whereas with old TI Forth, the whole system was in the upper and lower memory, the RAM, and you only had about 7K of upper RAM taken up by the system, the resident dictionary, and then what was left you had to work with. Anyway, with the most common words in Forth, they are abbreviated very, very shortly. So print is dot. If you want to, you put a number on the stack, let's say 4, and you see the OK 1, the 1 following the OK means that there's one number on the stack. These are 16-bit numbers. The stack size is called a cell. If I want to print that 4, all I do is use the word print, which is dot, and it prints the 4. If I have numbers in memory and I know where that is, I can get that memory on the stack and use another word called fetch, which is the @ sign. If I want to put something in that location, I have a number on the stack, and I use store, which is an exclamation point. Most of the words otherwise tend to be what you might expect. You would have begin, until, to do a loop that was a conditional loop. You might have CR for carriage return, put a carriage return on the out to the screen. So if I hit let's see, if I do carriage return, I get an extra. You see the OK is on the next line, not the same line. So I just simply put out a new line. Okay, is that enough for preamble to get going with this program? There are a number of words that create words. If I want to create a variable, I use the word variable. In fbForth, as with CTIIWF before it, you need to put a number on the stack to store in the variable. With other forths like TurboForth, I think Brian Fox's CamelForth, a 0 is put in there for you, and then you later have to store a new number in that. So if I want to create a number, a variable for the number to guess, to hold the number that I'm going to guess in this game, I'm going to need to set it up. So I'll just do 0 variable mynum. That should be a good enough mnemonic. And now I have set that mynum up. Now if I type mynum, it's a word just like anything else. It's going to give me the address of the place in mynum where it's going to store numbers or retrieve numbers. So if I hit mynum, I get one number on the stack. I'm going to put this in hexadecimal and do a non-destructive print of the stack, which is .s. Dot, you remember, was print, so .s is print stack. And it shows the bottom of the stack with the vertical bar. A03A is where the value is. Yes?
You hit enter a few times because we're off the screen.
Uh-oh.
Or if you can clear the screen and go back to the
Maybe
top.
I can change the resolution of this. Do try 800 by 600.
Try 480 by,
Well, it's not showing me that as an option.
Oh, there you go.
there you go.
Does that work?
Yeah.
Okay. Well, it suggested I do that anyway. I should have listened. I'm just hard-headed like the most of you are. So. Anyway, so, okay, A03A, when fbForth 2.0 starts up, and you were to do, if you were to execute here, which will tell you what the next available dictionary location is, it would be A030. So you see that definition of mynum has taken up A locations, which is 10 in decimal. Anyway, now if I fetch that number, I now have a 0 on the stack, which is what we put in it to begin with, 0 variable mynum. All right, now let's put a number in there. Let's put, let me go back to decimal and get rid of that number and put, is the whole thing on there? Okay. And put, let's put 45 in there. 45 store. Uh-oh, that's not going to work. Why isn't that going to work?
You need a place to store it.
What's that?
You need a place to store it.
Yeah, I need to put the storage location. So the storage, the order here is 45 is the number I want to store, and mynum is where I want to store it, and store should put it there. So now if I do a mynum fetch and print, it should give me 45, which it does. All right, so there's the first part of our little program. The next part we'll call new num, which is going to give us a random, well, pseudo-random number, and it's going to store it in mynum. Okay, I gave you one word that defines, that defines other words, which is variable. The one that's most commonly used is colon. which is to define a high-level fourth word. So I'm going to define a word called new num. Everything in fourth is separated by, anybody? Spaces. One or more spaces. So colon, new num, that's going to be the name of it. I'm sorry, we already have new num. This is going to be get num. Nope, I was right. I'm getting ahead of myself. New num is when I want to have a new number generated by the system that I don't know about, so I can guess it. All right, new num. We're going to do a 101 RND, the random number generator, pseudo-random number generator in fbForth is RND. It needs a number on the stack to use as a range. And what RND will do is to generate a number from 0 to 1 less than the number that you give it. So this will give us, I'm sorry, 1, is it going to be 0 to, it's going to be 0 to 100. It'll generate 0 to 100. Okay. So that generates the number, puts it on the stack, and now I need to store that in my num. So my num puts the address, store. To end this definition, I use a semicolon. All right, so now let's execute it, which is the beauty of fourth. You can do this right away. New num should have generated an unknown number and put it in my num. So let's check that. My num. Well, there's another word we can use that will both fetch and print, and that is question mark, which I forgot what the official name of that word is, but there, it generated 13 for us. All right, now let's define another word to get that number, get a number from us. I guess let me see here. How have I got this? Get num is going to prompt us for a number. Okay, we'll generate a carriage return, and then we will use a word called print string, which is dot quote. Print string, question mark, and that's the end of that. And then we'll do query, which will wait for an input from us and put it in the terminal input buffer. And then, yes?
Get num, you need a semicolon, right?
No, I'm not through with the definition. I can do this. I can hit the carriage return. It's just like hitting a space at the input prompt. Okay, query, we'll put it in the wait for us and put it in the terminal input buffer. And now I need to parse that, and BL is blank. That's the delimiter for word. Word will parse my input and use blank as a delimiter, and it'll put it at here, put the result at here. Okay, yes sir?
Does blank include space and carriage return and all those things?
Blank is just space. Oh, well, see, the carriage return is not actually entering a carriage return. When I stop my entry, it's putting a space and nulls in the terminal input buffer. It's carriage return. If I say blank, it's only going to do it with blank. And what will happen with Word is that it will go up to a blank and stop, or if there's no blank there, but a null, that will terminate the input as well. That's an unconditional termination. Okay, so we have blank word will get me one token and put it at here with the character count in front of it. Okay, let's see. That's all I need for that line. Now I need to tell a word called number where to find the token, and that would be here. and the word number will take whatever it finds there, try to convert it to a number, and it unconditionally converts it to a double number, 32-bit number. So,
Is that a,
Yes, sir.
an fbForth specific word number? Or is it standard forth? I don't know.
it's standard, although there may be a number question mark may be what's used in TurboForth and possibly CamelForth. This is all based on figForth, which predates even Forth 79. It was before that. So number will unconditionally attempt to convert the number it finds at the address you give it into a 32-bit number. Since we know we are dealing with a 16-bit number, the upper 16 bits is a 0, so we can safely drop it, which is the next thing we'll do. All right? Now, we have the number, and we have the address of the number, or actually the number we're going to store at this point, and now I'm going to store it in mynum. Mynum. Now what's going on here? I've got to store. Oh. Mynum. Yeah, I'm just. Oh yeah, guess is going to do the get num. And I need to define it before I use it. So here I'm going to use the address of mynum, get the number there, and subtract it from the number that we just entered. And then there's a word called SGN. I can't use sign, SIGN, because that's used in number formatting, so and I had no choice with that. So I invented this word SGN that will give me the, if the number is positive, it'll give me a +1. If the number is negative, it'll give me -1. If the number is exactly 0, it'll give me 0. So SGN will tell me what the difference is. And we should be able to use that right now. So let's do getNum and give it, well, we know the number is 13. Let's just give it 14 and see what we got as a result. We got 1 because 14 minus 13 is positive. All right, we're done with that. Let's now define guess. Give us a prompt with the print string. Somebody want to tell me what I should ask the user for? Guess a number 0 to 100. All right. Let's see. Let me.
I love that natural lowercase.
Yeah.
Nice.
Yeah, it's got true descenders too on it. Those were my own design. The rest of it, I don't know. I picked that up from somewhere else, but I don't know who I stole it from. It was a long time ago. Okay, did I finish that? All right. Now I'm going to go into a loop, which we start with begin, and we either end it with again, which is an infinite loop, or we end it with until, which looks for something on the stack that is non-zero to stop. If it's 0, it'll keep going. So begin, and I'm going to use another construct called case, and you can do it looks for the number that's on the stack, and then there are a series of end of clauses that if the word, you put a number before that, if the word is equals that, then what's on the stack, if that equals the number, then that of end of will be executed. In other words, it just keeps on going. And I also designed a word called end of, which is an unconditional. It's sort of like default in C on a switch statement. It will, if none of the others work, that one will. But we don't need it in this case because it can only be 3 numbers. 1, -1, and 0. Sign will not give us anything else. So I can safely use just those three. So case 1 of, okay, if it's 1, we guess too high, so let's tell them that. Whoops.
Too huge?
Uh-oh. Okay, I screwed up. Now what do I do? Let me end and see what happens. Okay, definition not finished. Forget guess. I'll tell you about smudge another time. Okay, guess. CR.
Hal, are we trying to stream today?
Yeah, we are.
We are streaming?
Yeah.
I'm sorry?
Oh, I was asking, are we streaming? Matt Haggerty's
Yes,
asking.
yes, we're streaming and recording, so if anybody has any questions about this at home, you can download these things and review it.
Okay, back to what I was trying to do. 1 of too high. Did it again.
Did Getnam belong in the middle of that?
Yeah, I'm going to ask the user for a number at that point, and that's what get num
I'm
is.
just saying you missed the previous incarnation, that's why I
Oh, let me see. Guess, CR, oh, I put that on the same line that this time. The CR, guess a number?
asked. Right, no, that first whole line is the same. That you
Okay.
said begin. If you look at the above one that you messed up
Right.
on, you went to case, but here you went Getnam and then you went to case.
Well, that's because I screwed up the first time.
There we go.
So it was a good thing that we made this huge mistake. Good one,
It's all
good
planned,
one.
guys. You got
Okay.
it all figured out ahead of time.
Too hot, right.
That's why I had to look.
Yep, well, okay, I would like to say I planned that, but you know better than that. Okay, that should be right. Now I'm gonna do a -1 and say of dot quote too low. And, oh, the 0. Does anybody have an idea what I put in the 0 in there each time? Remember I said I don't know if I said we're gonna use an until on this one. So if it's too high or too low, I wanna go back through the loop and get another guess. So I want 0 to be there ready for until. Now, if it's 0, what shall we say?
You got it.
Okay. This time I don't want a 0. We're done. Now there's a better way to do this. Entering. And it's called edit. We go to a block, we edit all this stuff, and then we load it, and if it doesn't work, we forget everything and re-edit. What I'm doing here, I have a working program if I don't screw it up by entry. So we can do it this way and test each word. All right,
Lee,
Yeah.
you didn't need a space after it says too high with the dot. You didn't need a space between that and your close quotation there?
no, what print string is looking for is a quote.
Right.
If I actually wanted a quote in the middle, I can't. It's, there's no provision, I can't do a double quote because it's gonna stop when it sees a quote.
Yeah.
If I actually, well, that's the case.
So if you open with a dot quote, you close with a dot quote.
The dot, no, I close with a quote.
Right.
It's fortuitous that it's a dot quote.
Yeah.
The dot is, the fact that it's right in front of the quote has nothing to do with how it started.
Oh, that's what I was asking.
Yeah. No,
And
all I need, all dot quote needs is to find a quote.
Just anywhere.
It doesn't, anywhere, it doesn't need a space before
Okay,
it.
that's what I was.
Because it's not actually a word at that
But
point.
that's why there's a space after the first quote.
Right.
Because the
Right.
first dot quote is actually a word.
It's a word.
Right, and it has to have a space.
Gotcha.
Otherwise, it's going to continue. If I'd said dot quote TOO,
Yes.
it's going to look for a word, dot quote TOO.
Yeah.
Okay, end of. Now we're done with the case, so I can do end case. And now, the last thing is until, and until is going to test the stack for a non-zero or a zero number. If it finds a zero, it'll continue, it'll go back to begin. If it finds anything else, it will stop.
And
Oh.
it will consume that zero, right? You take it off the
It
stack.
will indeed, yes. Okay, let's see, can I do guess? Yeah, let's execute guess and see that it works for us. GUESS, boy, that doesn't look right,
It's perfectly.
It is correct.
but I'm too close to the screen. All right, guess a number. We know it's 13, right? So if we say 13, we got it. If I hadn't, let's, what was that?
The Wumpus wins.
Yep, there you go. If I do guess, and I guessed 23, too high, 1, too low, 13. Okay, so it works. Now we're going to define another word called, if we want to continue, we can call it another. A-N, whoops. Yeah, that's right. Another. And here, we'll issue a carriage return to the screen. And what question shall we ask?
Play again.
What? Play again?
Does the question mark have to be separated from another?
No, it's part of the word.
Okay, just making
I made it
sure.
part, yeah, I made it part of the word. Play again. Oh, let's do. Something like that.
Yeah, that works.
Okay, end it with the quote. And now we want a word that's gonna wait for a keystroke. And that would be key. It'll wait for a single keystroke, and we're going to, there's a word called ASCII, which I unabashedly stole from Mark Wills. ASCII Y. So that will put on the stack the ASCII value for whatever follows it, which in this case is Y. Equal will test whether your guess, whether what you type is equal to Y. And that's all we care about for this one. Now, there's one thing I could do if in case a person is using upper lowercase, the caps lock is not down, if they're using the TI, and that would be to AND a capital Y value with whatever they respond so that uppercase and lowercase would both work. Fortuitously, actually it's probably not fortuitous, it was undoubtedly on purpose that the ASCII code was designed such that the lowercase is exactly 1 bit, the same bit, more than the uppercase. So it's easy to AND uppercase if you want to limit it to just that input. Okay, so another. Play again. Okay, what do you expect that 1 is on the stack? I hit, oh, you don't know what I hit. I hit N. So that should be false, right? Which is 0. Now if I do it and type Y, that should be a 1. Which it is. The one thing I did not like about fbForth, but I really, there's not much I could do about it, it's just tripped me up a few times in the past, is that true is usually, these days, all ones. So it's, if for 16 bits, it would be FF hex, and false would be 0. Of course, we know that anything that's non-zero is treated as true, but it has tripped me up to know that it's only going to give me a 1 and not -1 or FF. But that's the way it is. All right, one last thing is the game. Let's define it. We'll call it high-low. Is that okay?
What's the maximum number of characters you can have in a word? So like if another is 8
Um,
characters, is it?
That depends on the implementation of Forth, but in fbForth, as with CTIIWF actually, it's 31 characters you can use. If you want to type that many, 31 characters. So you can actually,
Haiku is a
there-
name.
okay. Yep, yeah, you can use 31 characters. Now, I had to correct something that CTIIWF, there was a mistake in CTIIWF, well, a bug, where that if you went beyond 31, it would let you put them in, but it really royally screwed up the header. Because the first byte has 3 bits defined for the word definition. One is a terminator bit, which also is at the end of the word, the name. There is the smudge bit, which will toggle on and off, allowing find to find the word. Usually that bit is on so that while you're defining a word, you cannot put the name of the word inside the word. Now there's a provision for allowing that so that you could do recursion, but normally you don't want to do that. And then the third bit is the precedence bit, which defines whether or not the word is supposed to execute while you're compiling, while you're defining a word. And so you got those 3 bits, and you only got 5 left. And that, all ones there is 31. And that's the length.
But that's
So-
the length of the word, of the
The
type
name of the
the
word.
name of the word.
The name of the
How
word.
many, how long can it be?
How long can the word itself be?
Right.
What,
It can be
you can fill up memory with
Right.
the,
So
which
just
is
one
not a
bit.
good Forth thing. You try to keep things short in Forth. Mainly so that you can do things like we've been doing, testing it as we go. We can execute everything we do along the way. Okay, so.
You can have a block, an entire block that's just one word.
Exactly right. And in fact, I have, although CTIIWF manual said, don't do that, don't go beyond 1 block, I tried it to see if it would work, and it does. And you can actually have more blocks. But you know, any word that's going to take you even half a block is probably too long. For those kind of things, you maybe should write that word in assembler. Which is, you got a very nice assembler in Forth. That works too. Okay, let's do this last thing and play the game, and then you can say goodbye to me, which is probably a good thing. As I go on and on, I usually do. Okay, high-low. Paige will clear the screen and put the cursor at the top left. And then we'll use randomize to give us a start that is hopefully unpredictable. We'll go into another loop, another conditional loop. Begin, we'll get a new number in our variable, mynum. We will let the user guess, and then we'll ask after he or she was successful if they wanted to play again. And if it's equal to 0, that is false, then we'll get out of this, because that will give us a non-zero number on the stack for until. Okay, and we'll end the definition. Now, let's play it. Okay, somebody give me a number. 7? Next? 7, what'd you say? 17. Still too low.
99.
50, I heard first. Too low.
81.
Ah, somebody's going into the binary. Too high.
43.
No, that we already know that's too low.
75.
75. Too high.
70.
What?
65.
55.
Ha! Okay, we'll play one more? All right. 50? Okay, next. Yeah, let's do the binary search. Okay, too low. Oh, come on, Hal, that's not binary. 99.
Oh, yeah, good finale.
Psychic.
99.
Again? One last time. Number?
50.
32.
16. 24. 28. 30.
Okay, you got it.
Okay, we got it. All right. We'll say no. Okay. That's it for me, except to just tell you that I have the manual back there. It's $14.99 on Amazon, but we'll do it $12. And I have a few fbForth 2.0 cartridges. I have two. Currently, I can make some different, more, but there's 2 black ones and 3 gray ones. So that's it for me. Thank you all for slogging through.
Thanks, Lee.
What? Yeah. Okay. I guess just undo this.
Thank you very much, Lee. That was entertaining, and believe it or not, I actually understood that. And that made your presentation was really wonderful because I break into applause if I see someone dial a telephone correctly, and I'm not much of a programmer, but I can just about make my name scroll across the screen. Now, Norm, you're going to be our next presenter if you're ready. Okay, come on up. And Norm has become one of our international travelers. He attends the various trips in